In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. The name comes from Hawaiian and translates to scout or visitor from a faraway land. Because of its characteristics, scientists soon began to wonder if this was, at last, a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was whether this was a comet or an asteroid. They are both celestial objects orbiting a sun, but have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright, glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet because it seems to come from a different location in the universe. Yet it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by. Even though it behaves like a comet, it looks more like an asteroid. Another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, we've been incredibly lucky with our detections, or it simply wanted to be seen. Another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often, massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptunes farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe, panspermia. This hypothesis suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, the building blocks of life, between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is that it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device you've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before, either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it is throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do, but the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. Hey, did you hear about the Philae spacecraft and its wild ride on a comet called 67P back in 2014? It was supposed to have a smooth landing, but things went haywire when parts of the device failed to fire, and Philae bounced off the surface like a rubber ball. It was like a scene out of a cartoon. Luckily, Philae managed to send signals back to Earth, confirming it was still working, but no one knew where it ended up. It was a mystery for almost 2 years until new images from a nearby probe revealed Philae's awkward position, lying on its side with its spider-like legs in the air, wedged in a shadowed crack on 67P. It gets even better. Philae's data suggested it had made a brief second touchdown that lasted only 2 minutes, and scientists had no idea where it happened. It was like a game of cosmic hide-and-seek. One planetary scientist from the European Space Agency said that Philae left them with, quote, one final mystery waiting to be solved. The good news is that scientists were able to uncover Philae's second touchdown site and learn more about the surface of 67P. It turns out that when Philae bashed into the surface, it scraped away a layer of dust and debris about 10 inches deep on the surface of the comet, revealing its icy interior. The ice was so bright that the team could see it even in images taken almost 2 years after Philae's crash. It was like uncovering a secret treasure hidden deep in the comet's belly. And there's more. The timing of the crash allowed scientists to calculate how soft 67P's interior was. By analyzing data from a magnetometer within Philae, they noticed a significant spike right around the time of the second touchdown. The spike lasted for about 3 seconds, and the team concluded that the comet's interior was about as soft as freshly fallen snow. Imagine that, a comet with fluffier boulders than froth on a cappuccino. Now that planetary scientists have a better understanding of a comet's physical characteristics, they can plan for future missions with much more certainty. And that's where things get exciting. The hope for a future project named Ambition would be to return, for the first time, a cryogenically stored sample from a comet's interior to Earth. Philly lander may not have had the smoothest landing, but it sure gave us some wild and wacky cosmic adventures. When it comes to comets, probably the star of the show, wink, wink, in the comet world is Halley's Comet. As a periodic comet, it visits Earth every 75 years or so, which means that you have a chance to see it twice in your lifetime. The last time it came by was in 1986, and it won't return until 2061. The comet was named after the English astronomer Edmund Halley, who realized that 3 comets seen in 1531, 1607, and 1682 were the same comet returning again and again. He predicted that the comet would return in 1758, and it was named after him, even though he wasn't alive to see it. Halley's Comet was first seen in 239 BC, and ancient Asian astronomers, that's a mouthful, recorded its passage in their chronicles. Back then, people believed that comets were omens of great disaster or change, but we know better now. In the 1900s, the writer Mark Twain joked that he came in with Halley's Comet in 1835 and that he expected to go out with it. He passed the day after the comet's closest approach in 1910. Wow! The comet Hale-Bopp also gathered some attention back in 1997. This comet was so bright that people could see it with their naked eye for about a year and a half, especially in the northern hemisphere. In fact, it was 1,000 times brighter than Halley's Comet. Even folks in heavily lighted areas like Chicago could catch a glimpse of its blue and white tails. The Hale-Bopp comet was discovered by Alan Hale in New Mexico and Thomas Bopp in Arizona. They were just gazing at the sky and suddenly saw this fuzzy object nearby that wasn't there before. Astronomers were excited about this event too. They used telescopes to study the comet as it approached, and NASA even used the Hubble Space Telescope to get a better peek. Hale-Bopp's nucleus was huge, like 19 to 25 miles across, and there was a lot of dust streaming out from it. Now, speaking of Hale-Bopp, the pop song Bop by the Hanson Brothers was a worldwide hit in that very same year, 1997. Is there a connection, anyway? 5,000 years ago, another comet swung by our sun and put on a show for civilizations across Eurasia and North Africa. Unfortunately, this mysterious visitor wasn't recorded in any historical accounts, but scientists have a sneaky way of figuring things out. Enter Comet Atlas, or C 2019 Y4, which made its debut in 2020. Sadly, Atlas met its end when it broke apart into a shower of icy fragments. But in a new study using NASA's Hubble Space Telescope, astronomers discovered that Atlas was a broken-off piece of that ancient comet from 5,000 years ago. Talk about a family reunion! Comet families are not unusual, and one of the most famous examples is the doomed Shoemaker-Levy 9 comet that fell piece by piece into Jupiter in 1994. But Atlas is a bit of a weirdo. It broke up while it was far from the Sun, which is strange because it should have broken up during its closest pass to the Sun. How did it survive its last pass 5,000 years ago? Well, by observing the breakup of the fragment, scientists can learn more about how the parent comet was put together. They discovered that one fragment of Atlas disintegrated in a matter of days, while another piece lasted for weeks. This suggests that part of the nucleus was stronger than the other part, but the explanation for why it broke apart is still up in the air, pun intended. It could be due to centrifugal forces, or it could be because of supervolatile ices that blew the piece apart like a firework. One thing is for sure, though, Atlas's surviving sibling won't return until the 50th century. So until then, we'll have to settle for admiring the other beauties of the night sky. This next funny story is about a bunch of astronomers on the island of Maui. One night, they were just chilling and gazing at the stars with their fancy telescope when they suddenly spotted something weird. It was a comet, but not just any old comet. This one was traveling super fast and had a really strange shape. It was so odd that they even thought it might be a spacecraft from outside our planet. They named it Oumuamua, which means a messenger from afar arriving first in Hawaiian. Now, I know what you're thinking. Did they find a new civilization living in space? Well, not quite. But what they did find was pretty cool. You see, when comets pass through our solar system, they usually speed up as they leave because of the sun's gravity and the dust on their surface. But Oumuamua was too small to have any surface dust, so it didn't have the same glowing halo as other comets. So, what was causing Oumuamua to speed up? One possibility was due to a strange effect where small bodies like asteroids absorb photons from the sun and radiate them in a propulsive plume. But that effect was too small to explain Oumuamua's acceleration. That left three possible explanations: propulsion provided by nitrogen, carbon monoxide, or molecular hydrogen. And guess what? One theory is that Oumuamua was rich in water, which is made up of hydrogen and oxygen. Some believe that before the comet entered our solar system, the water froze into ice in what's known as an amorphous state. This type of ice is porous and dotted with pockets, like my jeans. The theory then goes on to say that cosmic radiation caused some of the hydrogen in the water molecules to break away, collecting in the pores like fuel in tiny fuel tanks. When Oumuamua entered the inner solar system, it probably warmed up just enough for the ice to convert to its crystalline state, essentially closing the pockets and forcing the hydrogen out of the comet. This might have provided the propulsive push that could explain the acceleration. If this theory is correct, there are no cosmic neighbors, just some really cool science. Aloha! Some people, like the Andaman Islanders, a community living in the Gulf of Bengal, see comets as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think of them as flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably, one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks, to protect themselves from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets. And space objects in our solar system, its official title is 1P Halley, and it's named after the English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30, 239 BCE. Asian astronomers noted it down in the Shi and Wenthuna chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. The authors also noted a comet in the sky at the time the meteor landed. They also reported that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21, 1910, one day after Halley's had emerged from behind the far side of the Sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, with one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets in general may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small, rocky space bodies also orbiting the Sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately one great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the Sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there, otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's Comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996.